Okay. Today we're going to talk about logarithms. We did exponentials last class. Um, oh, I'm from home today because my other college is on spring break. Hopefully my husband shuts her up. Unless he went to get my son. No. Can you hear her? She's a Labradoodle and she likes to bark. My other dog is a Husky Poodle and she'll howl once in a while, but only if the mailman's here. Oh, good. I mean, it wasn't too loud. She wasn't right above my head, but I don't know. She barks too much. Okay, so logarithms. We talked about exponentials. A log is the inverse of an exponential function, so they kind of go together. According to data from the United Nations Food and Agriculture Organization, you can look at like the things in the back have 109. Usually I take that off, but that's just showing you the source where they got it from. The forested areas in square miles in 2 countries, Benin and Brazil, 1990 and 2015 are in this table. Which country suffered the greater amount of deforestation in that period? So we wanted to see which one had more deforestation. Notice 1990 to 2015, this went from 22,600 to 17,000. And this one went from 2 million and some to 1.9 million. And so they were big drops, but how could we look at those? One way we could do that is to subtract them. If we subtract the years, we see it's a 25-year period. So we could find the differences by subtracting them. This was square miles because that's what it said here. So in Benin, it became, or they tore down 5,490 square miles of trees. In Brazil, getting 204,000. So they tore down 204,000 square miles. Sounds like a lot more. I mean, it is a lot, no matter how you look at it. That's called absolute change. The two values are subtracted. That's absolute change. Your newer value minus your original. And it keeps the same units, square miles. So when you just subtract them, that's absolute change. And that definitely shows us that Brazil tore down more trees. But they didn't, the Benin didn't have as many to start with. So proportion wise, you can't really compare them. Although this is a lot of trees to be cutting down. If they have a lot of forest, maybe they should preserve their forest. But to see the percentage compared to how much they have to begin with, that's relative change. So sometimes it's better to just subtract them and see the difference. Other times, relative change is a better option because it shows you the percent difference, and then you're comparing them on the same grounds. Because this one's so much larger than this one, maybe it's better to look at the percent. To find the percent, new minus the original divided by the original. So original would be the size of the forest in 1990, and this would be the new size. Now the book uses Q sub 1 minus Q sub 0, and who knows what those stand for. I like using words whenever possible, because then you remember what they are and what they stood for. So if you look in your book, I think they use Q for quantity. Q sub 1 minus Q sub 0 over Q sub 0. In another book, it will use different values. I mean, different variables. But it's just new minus original. Now, notice new minus original is absolute change. So you could just do absolute change divided by the original. Or you can do new divided by original minus 1. Any one of the three, whichever one you're going to remember. Now this will be a decimal because it's going to be a rate. So to make it a percent, if you want the percent, you multiply by 100. So relative change makes it a rate or a percent, rather than keeping the same units like this kept square miles. Any questions so far? Okay, absolute change. I did that first. It's up there. You're just subtracting them. Relative percent change. I prefer new minus original divided by original because then you remember what you're dividing by. That's what I use. But you can use absolute change also because we already subtracted them. And then you just divide by the original. So if we look at Benin, new minus original was 54.90. Divided by the original, which is the 22,640. Wait, I subtracted it. These should be negative. I subtracted the wrong way. The values are correct, but you should subtract in the other way because you want the new value, which was in 2015. And the reason you want to go the opposite way is because this negative means a decrease in the number of forests. In my calculator, I always do larger minus smaller. I just know it's supposed to be negative. Because either way, you're getting the same answer, but it should be a negative because you're losing forest. So these should be negative. So here then we take the subtraction, negative 5,490, and we divide by the original, which was 1990. We're going to multiply by 100 because we want to make it a percent. I'm going to go 2 decimal places. So that 4 will become a 5. 24, 25. 24.25%. And it's negative because it's a decrease. So they cut down 24.25% of their forests. Almost 1/4 of them. Brazil, we've already subtracted. So we have a negative 204,000 divided by their original. And multiply by 100 to make it a percent. I'm getting, probably should have just went 1 decimal place, but 9.5%. So Benin cut down a lot more than Brazil. Any questions on that? So it's 2 different ways of looking at it. Subtracting it shows you that Brazil cut down a lot more of their trees than the other country, but here it's showing that percent-wise it was a lot lower. And the negative is because they were cutting down the tree, so it's a loss. Any questions? Let's try another one. The yield of soybeans on a certain test plot is 51 bushels per acre. An adjacent plot, similar in all aspects, is planted with a new genetically modified variety of soybean, and it yields 57 bushels per acre. Find the absolute change and the relative change, and which is the better way of describing it. So first we find absolute change. Absolute change, you're just subtracting them. New minus original. They'll also see new minus old, or reference. Sometimes they'll put reference value. So the new one, the new modified variety, is 57 bushels per acre. And this one is 51 bushels per acre. If we subtract them, we have 6 bushels. So the new modified soybean gets 6 more bushels per acre. I think that's a good thing to see because they're both the same amount of land right next to each other. Find the relative percent. I always put percent change because it's easier to talk about a percent than a decimal rate. Relative change is the new minus the original divided by the original, and we want to make it a percent, so we're going to multiply by 100. New minus original, we already did, it was 6, divided by the original, which was 51, times 100. I'm going to go 1 decimal place this time. The new modified soybean So the new soybean produces 11.8% more beans than the original soybeans. Any questions on that? So absolute change just shows you how much more or less of the same units. Relative percent change gives you a percent or a rate, depending on how you want to write it, and tells you more, I don't know, more about it. If your units are different, or maybe you're talking about oranges and apples, percents work better. So it just depends on how different they are, size-wise, product-wise. Any questions on that?
I have a question.
Mhm.
All right, so on the notes, under relative change, it has the new minus original over original equals absolute change over original equals new over original minus 1.
Mhm. This is another formula you can use. Any one of these 3 will work. So this last one,
Oh, they're all different? Okay.
yeah, I mean, they're just like new minus original is the absolute change, because your absolute is new minus original. So instead of that, you could say that. Now this one, what they're doing is they're taking this part here, new. I just wanted to put it there in case you looked in the book. Why does that not look like I'm spelling it right? Oh, I got an extra N in there. So if we start with this, the way they're getting this is they're dividing original into both of these. So they're taking the denominator and plugging it into both parts on top, or dividing it into both parts. And then original divided by original, that's just 1. So they're just saying you could use this version, you could use this version, or this one, but they're all going to get you the same answer.
Thank you.
In your calculator, there's a function for logarithms, and they're the inverse of exponential functions. Without a base, if it's just log, then it's base 10. So written like this is log base 10. Let's find the values just to make sure we know how to plug them into our calculator for 1, 2, 5, 7, and 10, just to make sure. Piece of paper. So we want to find the log of 1. When there's no value, that's a base 10, and that's what calculators are. They're base 10. The log is either somewhere here on your calculator or here. Now, if you don't see it, then you probably have one that says trig or math. Sometimes it's under math, but you should have a button that says log. So to find the log, we push, oops, let me clear my screen. You push the log button and then type in your 1. Now, the book's going to tell you 1 and then hit log. Well, that depends on your calculator. If you have a calculator that's very old, then that might be the case. You have to hit 1 and then log. But most calculators, I don't have my other ones down here for some. The ones I have, though, all of them, I hit log first and then 1. So find out how you use your calculator, plug it in, make sure. Log of 1 is 0. Is everyone getting that? Is there anyone that uses Desmos as their calculator? It doesn't have a calculator? Anyone? No one uses Desmos? Because if you do, I'll show you where the logs are. No? Okay. Let's find the log of 2. Now, some of these are going to have big decimals. Well, I don't know. I didn't say what to round to. So let's round 2 decimal places. If we need to round 2. So when you plug in log 2, you should be getting 0.3010299. Well, this is how far mine goes. Yours may not go that far. Rounding 2 decimal places. Any questions? Okay, find the log of 5, 7, and 10. You're getting 0.70 for 5. For 7, I got, yep, 0.845098804. 2 decimal places would be 0.85. And the last one is 1, because this is base 10. when the base and what you're taking the log of are the same, it leaves your exponent. So if we had log base 10 of 10 to the x, our answer would be x, whatever's in that exponent. But of course, base 10, we can just plug in our calculator. Any questions on those? Is everyone getting those values? Because the biggest thing is being able to plug them in. And I think the homework for today is just plugging in. I think I put a log and an exponential one to make sure you understand how to plug them in. Any questions? Okay. There's two rules you need to know. When you have the log and it's being multiplied, it can be broken into an addition. So you could break up the log and go the log of A plus the log of B. When you have an exponent, you can bring that exponent down in front and have y log x. There's also a division. I think they bring it up later. Let's have that now. That way you have them together. If you have the log of A divided by B, just like multiplication becomes an addition, division becomes a subtraction. The bottom one is the one that gets subtracted. So multiplication, you can separate by addition, or vice versa. If you have addition, you can combine them into a multiplication. Exponents can be moved down front. And division is a subtraction. Okay, let's try checking law 1. We're going to find the log of 5 and the log of 12 and to see if it's the same as the multiplied together. Let's go 4 decimal places. So find the log of 5. Sometimes if you don't go far enough, it'll be a little off. So 4 should get us an exact answer, but we'll see. So log of 5 is 0.69. If I go 4 decimal places, that 9's going to be a 0. So then that's going to be 699. Finally, log of 12. 1.0792. Now I'm going to add these together.
Are we allowed to round up like a decimal point?
Yeah.
Okay.
Yeah, like this one here would have rounded up because it was 89. And then this one, the 1 became a 2. But I'm going 4 decimal places because I don't know if 2 decimal places will get an exact value, but I think this will. So then this one, we want to take the log of 5 times 12 or the log of 60. But you can actually put log 5 times 12. Now it's a little bit different. 7, 7. No, it's not. It worked out exactly the same at those decimal places. Because the 1 will go up because that's a 5. So they are the same. Any questions on that part? To show the second law, this is 7 squared. So if we find the log of 7 squared on my screen, log 7 squared. $1.690. The 1 is going to change to a 2 because of that 9. Now from this rule, that exponent can be brought down. So this 2 could be brought in front. That's what they're doing here. They're taking the exponent and bringing it down. We can find 2 of the log of 7. So I didn't hit 7. There we go. Exact same value. Any questions on that? Okay, we just could do the same thing here to check it. Say we started with the log (5) divided by 12. Using this formula, we can break that up into a subtraction. If we calculate both sides, they should be the exact same answer. So if we look at the first one, log 5 divided by 12. So shut up on me. Log 5 divided. Now I'm going to type this all at once. Oh, we do have the values here. 5 and 12. So the log of 5 is 0.6990. The other one is 1.0792. If I subtract them, you get the exact same value. Any questions on plugging values into the calculator? The biggest thing is making sure you know where the values are or the functions. Any questions on finding the logs? Now your book uses log. I don't remember if we got into natural log, but the natural log and the log, you can use either one. Natural log is the inverse of the exponential function. Notice it has the e to the x here. The log is the inverse of 10 to the x, because we said log was base 10. If you are in another class, or I don't know, we may get into other logs in this class. This chapter didn't show it. If it's a different than base 10, you cannot plug that into your calculator without changing the base. Some calculators, this one, I'm not sure. Under math, it has different bases that you can put. I think it's under number. No. I'm not sure. Maybe it's under trig. I know somewhere this calculator has different bases of logs. I just don't use it. Any questions though? The anti-logarithm is the inverse of the log, or what the log gives you. For instance, if we wanted to find x, and we knew the log was 2.25527, when there's no base, it's a base 10. So this can be written 10 log x equals 10 to the power. So that's one way of looking at it. And then you just take 10 to that value. So if I have I can take whatever the base is, when there's no base, it's a 10, and take both sides of that power. These cancel and leave x. And then it's 10 to the 2.25527. And then we just plug that into our calculator. 10 to the 2.25527. Approximately 180. Any questions on that? So if we look at this one, well, I don't know why they went from that to these, but for these ones, make a little more space here. Remember the formula? Right here. When we have an exponent, we can bring it down. Whenever you're looking for a variable that's in your exponent, if you take the log or natural log of both sides, you can bring that variable down. So we can take the log 2 to the y equal to the log 128. Because then this y can come down in front. And we want to divide by the log of 2. Because you want to get y by itself, since you're multiplying, you divide. Log 128, close the parenthesis before you divide by the log of 2. 7. I think this is on Tuesday's attendance problem. One like this. Go ahead and try the next one. I'm going to write it over here. When you get X, type it in the chat. Around 2 decimal places. You should be getting 4.62. We take log of both sides because the variable we're looking for is in the exponent. And then we want to bring our exponent down. Next, since we're multiplying by X, to get rid of this log, we would divide by it. And then log of 160 divided by log of 3 is 4.62. It's 4.6196222289. Any questions on that? Let's try the log one again. I mean, another one. Let's do. Let's leave a base 10. We'll do one of each. We'll stick with a base 10. 2, 5, 5, 2, 7. So the log of what value will give us this? This is a base 10. Since it's base 10, we take 10 both powers. Because in this is an inverse, it cancels. X equals 10 to the 1.25527, which is 17.999899617. Any questions on that? Log base 2 of X equals 16. That's going to be pretty large, but that's okay. Now, when the base changes, whatever the base is what you want to take it to that power. As long as this and the base match, it cancels. And then 2 to the 16th. You should be getting 65,536. Any questions on that? Is everyone getting the values? Positive. I don't want to start that next part. We don't have enough time. Is everyone okay with solving these? Any questions?
I'm confused. So whenever I do log to the 16th, aren't I supposed to be getting or no, log to the so if I do log to 65,536, I'll get 16.
Yes, there you go. Mhm.
Okay. Okay, I was
But now
confused.
this one's a base 2, so it may be a little bit different because your calculator's not base 2, but this one definitely was base 10, so the log of 18 will give you that.
Right, okay.
This
That
will be
makes
a little
sense.
off.
Okay, thank you.
You're welcome. Any other questions? Okay. The homework problems are just plugging in like the log, and then the next day I think is similar to these. So try those, and especially today's. If you have questions, let me know. And if not, I will see you tomorrow.
Thank you.
You're welcome. Have a nice day.
Thank you.
You're welcome.